Howdy, my name is Sam. I am a solutions architect at GitLab, and today I'm going to show you a Docker application that is hosted on AWS Elastic Beanstalk that is built, tested, and deployed through GitLab CI/CD. So if we look at my screen here, we'll see that I do have an environment called production, and this is actually linking to my production application or my currently running production application. So if I open this up, I can see my latest deployed production app. So this is my very basic app, and this is essentially what's running in my main branch and is based on my latest Docker image that I built in my CI/CD pipeline. So this is the end state, and we're going to take a look at how we got to here. So let's start by taking a look at my pipeline. So if I go to my pipeline editor, I can see what my CI/CD pipeline looks like. So we're going to go through kind of what this is and then dive into the code behind it as well and kind of the inner workings of the logic. So we start by building our Docker image based on our application code that I have. In this case, it's a Flask app written in Python with some HTML and CSS as well. Then we move into the review stage. So this review stage does a few different things. It essentially creates an application in AWS Elastic Beanstalk, as well as an environment for the application. It does this if there isn't an application and corresponding environment that already exists, which in the case of a production application, we wouldn't be creating a new application and environment. We would just be creating a version of the application and deploying it to the same environment that exists. The only time we're creating a new application and environment is when we open a merge request to essentially add a change, and we want to create a new review app. The review app is where you can see your live changes on essentially a staging website. So we do our provisioning. So again, either creating a new application and environment entirely based on a new branch being created for our merge request, or creating application version and deploying to the existing environment. We also want to check for environment readiness. So in this case, I have it check for if there is a dynamic URL or if there is a URL that has been assigned to the environment that we're deploying to for a review app. So this review stage only runs in the case of a merge request, right? Essentially, it is checking if the environment is ready. So there's a difference between successfully creating the environment and for it to have, OK health, ready to go, and have a URL that is assigned to it so that we can deploy our changes to the URL that is created at this stage. So we check for the existence of a URL here. And then deploy review. This is essentially where we actually deploy our review app in GitLab so we can manage our review environments back in our environments page that we started at, and we can click into there and it'll automatically redirect us to the URL in Elastic Beanstalk. The deploy stage, we have a stop review job, which essentially force deletes the application and environment of the branch that we're working out of. So that review app that was created, it'll be deleted in GitLab, but it also deletes the resources in AWS to do resource cleanup so you're not consuming additional EC2 instances and such. And then we have a deploy Elastic Beanstalk. This deploy job only runs in the case of merging to my main branch or my default branch, essentially deploys to that production URL that stays static, unchanging, and your main application URL. Finally, we have a DAST stage that runs. This will either run against our review app, so it runs against the staging environment and produces any results that you would see on your production application. So you can run a full active attack as opposed to a passive scan. In the case of running against production, I have a scan execution policy running DAST so that it runs a passive scan, non-active scan against our production running live application so that we don't have a chance of accidentally taking down our production application, right? So this DAST runs either on a review app, on a merge request, or it will run on our production app in a main branch update. So this is the pipeline logic. Let's take a look at the actual code for it. So again, we have our stages, order is important in our stages. This is our Docker build job. So essentially it is obviously using the Docker image, and it authenticates us based on our username and password into our CI registry. So what this is essentially doing is it's deciding what branch are we on and associating a tag with our image. If we're on the default branch, our tag will be latest. And if we're on any other branch that is not our default branch, it will be the tag will be a commit slug. So we assign our tag based on what branch we're on, right? And then we essentially build and push our image to our container registry, which we can see in the deploy tab right here. If we click into container registry, we can actually see all the containers that all the images that we've built. So this is the name of the app. I can click into this and I can see all of my images. Including latest, which was published 1 week ago. So this is essentially the entire container registry where we're pushing our images to. And we also make sure that this only runs if there is a Docker file that exists. Otherwise, we will not get very far trying to build our image. Moving forward to provisioning the application. So essentially I have some scripts that I wrote here. This is just because there's some reuse logic here. So you have to make these scripts runnable. They're all, bash scripts, including an AWS authentication script, which all you have to do is, create your access key in AWS, associate it with a variable in your project. You could also make a group level one if you wanted to. But it authenticates into AWS. You can use the Elastic Beanstalk CLI as well as the S3 CLI. So if we dive into what this script is doing, we can take a look at the exact logic here. So again, we have our authentication script, which we dive into first. This is reused basically in all the jobs that interface with AWS, where we want to set our access key, our secret access key, and our region. Then we provision our application. So essentially what this is doing is, again, it is checking if an application exists. If the application does not exist, we create an application in Elastic Beanstalk. And then we also, for every case, we always want to create an application version. So if the application already existed, we would just go straight to creating the application version based on the label that we assign it. And this label is going to show up in Elastic Beanstalk, so you can filter through and see exactly which version of the application that you're running, right? Similar deal, we check if an environment exists based on our review environment name. If it does not exist, we create an environment based on the application version that we created above in all cases. Otherwise, we see the environment does exist and we're just logging that to our logs, and then we update the environment with the application version. So that's what the provisioning is doing here. Similar deal, we are also doing update source bundle. We actually run this first, my apologies, but essentially all this is doing is it's diving into our file in S3 and it's replacing the tag. So in this case, like I said before, our tag for our review app image or our merge request image or our branch image, anything that's not our production image, is going to have the CI commit ref slug as the tag, right? So we already built our image and now we're replacing our default tag latest with the commit ref slug. And also providing the review S3 key. So we're creating a new S3 file, right? And we're placing it in our S3 bucket as well. So this S3 bucket stays the same. We're just creating a new file called whatever is the contents of our review S3 key. And the only difference is we're just updating the tag. So we're pointing to the correct tag in our container registry. And we're not always pointing to the latest because we do want to deploy the changes that are in the merge request that were updated on the branch. And this runs on everything except main. Again, you wouldn't necessarily do any of this for your main branch because your environment already exists, your application already exists, etc. And you wouldn't want to update the tag from latest because you want to use the default, which is the latest tag. So there's no need to update your source bundle or provision an application at this point. This is just for your review stage, and it only runs on branches except for main. So again, this environment ready job does require the app to be provisioned, of course, because you need to make sure that your environment is stood up and running. So essentially, this is running the script to verify environment ready. So let's jump into that script. And it's checking for the existence of the endpoint URL for the environment that was provisioned, and then providing an exit code. So this job will fail if there is no URL associated with the environment, which is the case for if it is not provisioned yet. It usually has a bit of lag in time before this URL is created. So I do have a retry. We only allow for retries up to 2 times. So this will rerun if that job fails until there is a URL. Finally, deploy review. So essentially we need environment ready to have succeeded. That means that a URL does exist for our environment. Again, runs in the review stage. And what this is doing is it's grabbing that dynamic environment URL, and it is putting it into this deploy.env file. And this is what is controlling the review app, essentially. And it's setting the variable dynamic environment URL to http:// because this is the beginning of the URL and the actual URL that was gathered in the previous step. At this point, we also set a DAST URL. I do have a DAST scan that runs against this dynamic URL, so I do want to port that into the environment URL.txt. This is essentially saying, I want to scan this URL instead of my DAST website URL, or whatever set to the DAST website variable, right? So typically I have that set to my production one, but in this case, I want to override it by adding this dynamic URL to the environment URL.txt file. Adding my artifacts, the deploy.env file, and this is when I actually create my review environment as well. So in this case, I call it review / and then the commit ref name, and I set my URL obviously to that thing that we set earlier, right here, the dynamic environment URL, and then on stop, I'll run the stop review. So if I click stop review app, then it'll trigger this job, the stop review job. It's a manual action. And essentially what this is doing is it's authenticating in AWS and it's deleting the application. We're looking at the review app's name, and then we're going to terminate the environment by force as well. So it's going to delete the application and the actual running environment on stop. So that's the case of the review app specifically. For production, this deploys to our production Elastic Beanstalk. So in this case, the environment is called production always, and the URL is the production URL, which I hard-coded in here. It's like your google.com, your example.com. It's your main website URL, right? Just defined in a variable called prod URL. I want this to be a manual job, so it is not triggered automatically. You can have automatic deployments and not have a when manual, but in this case, I want it to be a manual job just for extra security, only running on the main branch. Same deal, authentication. We want to create an application version. It's the same logic as the script or the same actions of the script we looked at before. But in this case, we don't need to check if there's an application that exists or an environment that exists. We just want to create my version using my source bundle that is, the S3 bucket that everything is stored in, and the prod S3 key. So that main file that has the latest tag in there, we're going to reference that here. And then we're going to update our environment. with the application name, environment name, version label that we referenced before. And this will update our production environment. In this case, the environment called production, I have it up as a protected environment so that we can't deploy automatically to it. I also have it set so that the person who approves the deployment can also trigger the deployment just as an additional separation of duty guardrail. Continuing forward, I do want to run DAST, so I do have my include template DAST for my DAST job. That is why the DAST job exists, is because of this line right here, include template DAST GitLab CI YAML. And these are all my variables that I specify. So, my production application name is Docker example, and environment name is Docker example environment. This now is unchanging. I have a prod URL that also is unchanging. In this case, I have the prod label and the prod key. And I have my DAST website is the same as the prod URL, right? So this gets overridden in the review app job that's creating the review app. It's also setting a different DAST website URL to scan. All right, so this is kind of the logic for the variables, controlling essentially, what file we want to point to, etc. This is the entire GitLab CI YAML file. Let's see it in action. So I want to look at a merge request. In this case, I added one line to my file. I changed my first post to Hello Solutions Architects. My merge request pipeline passed, and nothing happened in terms of a scan result policy, so we're good to go here. But what happened in my pipeline, right? It ran Docker build, so it created my container. You can see the output from that here. So it built the image, and it provides the digest upon pushing. Then all of my security scans run. This is managed in a compliance pipeline external from the project. So we didn't see any definition of this because we didn't define anything in the test stage. This is all managed externally because I have a compliance framework associated with the project. The review stage. So in this case, provision application ran. So you can see the logs of it. In this case, we saw the application did not exist because this is a new merge request. So we're creating the application. And we called it Docker example Hello Solutions Arc. So what we're going to do is we're going to go into AWS now. And in this case, it created this application right here. So this was automatically generated. And you can see here, you can click into the version. So essentially every time I commit to the merge request, I would have a new version, and that version label would be the commit SHA from what I committed to the merge request. Similarly, it has a source file. So this is what happened when we overrode the file in S3. We had a file called docker run aws.json. That is our main file specifying we want to pull from the latest image. What we did here was we actually created a new file, and we overrode latest with Hello Solutions Arc. So this is pointing to the container in our container registry, which we can take a look at right here. Click into it. It'll be on our next page, alphabetical. Hello Solutions Arc. So this is the image that we created. It has logs on when we did it and the digest. So this is the image that we base our changes on, and you can see it's in our container registry. All right, cool. So what that did was it overrode essentially just latest after this colon, so that we're pointing to the correct image. And we deployed that to an environment. So that's our application version. Going back to our application, we see the health is okay. And we can go into the actual environment name. We call it the branch name in this case. So hello solutions arc. You can see our health is okay. And from here, we could click on the domain and we can see it. We can see hello solutions architects. This is our review app, right? And we could click into this from AWS, but if you want to click into it from GitLab, you can actually do so because we generated a review app for it. So if I go into deploy review, this is when we deployed our review application because we checked the URL existed after a retry or not. And essentially, we see at the top here, this job deployed to review hello solutions arc. So if I click on that, I'm going to see my review app and I can view the deployment and it links directly to that URL that I clicked to from my AWS console. So that is a very handy thing. It deployed it pulled the image from our container registry and deployed a new version of the application to this review app environment. And if I created another commit to my merge request, it would do the same thing. It would build the image, push it into our container registry. It would see that the application exists, create a new version using that different source file that was created. And that source file is suffixed, I suppose, with the commit SHA of my commit, and it'll point to the correct image and deploy that to the environment that exists, right? It's a new version of the application, same environment, and then our review app will point to that environment regardless with the new changes. So this is, again, directly from GitLab. We click view deployment, and then we can see the deployment. You could also access the same thing from the deploy from the operate section. You can click into environments and you can see in review, we have 2 that are open right now because I have 2 open merge requests with running environments that I haven't stopped yet. And again, I could open the live environment from here. All right, great. And then after that happens, we do have DAST run. So again, we don't have anything in deploy except stop review because we're not deploying to production at this time. But we do have our DAST stage, and the DAST runs against the review app environment. So it's running against this URL and not my production URL right from the beginning. And it can give us some DAST results in here as well. So in this case, we can click into DAST and we can see the DAST run. All right. So again, if I clicked stop, it would delete the application and terminate that environment by force. If I clicked merge, it would deploy to production by building. It would build the image correctly. It would see that we're on the main branch now. It would build whatever my code changes were in this and create a new image based off of it, or update the latest tag with the changes, and it would deploy that to production, which can be managed in your environments. Once again, in operate environments, you can access your production environment from here as well. So that is a brief overview of how to use GitLab CI/CD to build a Docker image, store it in our container registry, and create a review application based off of the changes made in a merge request, deployed out to AWS Elastic Beanstalk, and you can preview the changes live on your review app, run DAST against it, etc., but also host your production application on Elastic Beanstalk as well. Thanks for watching.